Good. Excellent. Yeah, so that's here. So if we define deadweight loss to be the difference between the consumer surplus if price was equal to 0 and the consumer surplus plus profits when price is equal to P, then the derivative of deadweight loss is negative CS prime minus pi prime, right? Which is always going to be greater than 0 for a positive price. So we can use that to rewrite this as pi prime S prime CS is equal to deadweight loss prime times S. And this leads to a central sort of elasticity formula, which is very much like Becker's formula. In particular, the elasticity of innovation supply multiplied by the ratio of consumer surplus to profits is equal to the marginal deadweight loss divided by the marginal profits, right? Now, remember that when the price is very low, the marginal amount by which profits increase is very large compared to deadweight loss, because deadweight loss is a triangle and profits is a rectangle. But as we get towards the monopoly price, the marginal amount of deadweight loss is going to be significant, but the marginal amount of profits is going to be near 0 because we're approaching the monopoly price. So that's going to basically create a unique intersection between these two things, right? And that creates our optimal intellectual property policy. OK, so following exactly the same sort of logic as with Becker, we're going to have higher intellectual property protection if the elasticity of innovation supply is greater, right? If there's more deadweight loss on the margin per unit of profits on the margin at any given price. We're going to have less intellectual property protection if there's more deadweight loss per profits. And if the ratio of consumer surplus to producer surplus is higher. OK. So one simple way to try to look at this is to think about a constant pass-through demand curve, because we know that pass-through affects these properties about deadweight loss per unit profit, right? It turns out that the constant pass-through demand class includes constant elasticity demand, exponential demand, and linear demand as special cases. So it's sort of like a useful class to look at. So in that class, quantity is equal to 1 minus the pass-through rate times price to the pass-through rate over 1 minus the pass-through rate. Evidence that's available, though it's not great, shows that often pass-through is between 0.5 and 2, so I'm going to consider that as the relevant range. And we can use this to think about optimal intellectual property protection. So on the left, what I've done is I've moved from a low pass-through rate to a high pass-through rate. Increasing the pass-through rate moves us up to these higher curves. Now, both sides of the equation increase because the ratio of consumer surplus to profits rises, but also the ratio of deadweight loss to profits rises on the margin, right? So that leads to a higher total social value, turns out to lead to lower optimal intellectual property. Because I guess the deadweight loss part dominates. I'm not sure exactly why, but it turns out to. On the right-hand side, we have the elasticity of supply increases, and we get an increase in the optimal protection. Now, the thing to note is that we could separate the deadweight loss part from the consumer surplus part. Because if you were to look at the slope of the pass-through rate, how it changes as you move along the demand curve, that will directly affect how much is deadweight loss versus how much is profits, and therefore will give you a cleaner comparative static. And I have a demand system that does that, but I didn't include that here because it's a little bit more complicated. OK. Anyway, if you look over the range that we were thinking about, the evidence we have on elasticities suggests again, this is not great, but there are a few studies on this, that elasticity of innovation supply is often somewhere between 0.5 and 1. And if you consider both of these over the parameter ranges considered, you'll get that optimal protection is somewhere between 0.5 and 0.65. So what does that translate into in practice? So Stig, how might we be able to interpret the degree of intellectual property protection in terms of things that we actually see in the real world happening?
I guess what's so the amount of pass-through changing, like the
Well, just like what are policies in the real world that governments take that affect how much intellectual property protection there is?
I mean, like when you have a lot of intellectual property protection, like here, then we get a lot of innovation. Like China doesn't have very good intellectual property protection. They have, like,
Yeah, I'm looking for something even simpler. Just like what is it that we do that China doesn't do that makes us have higher intellectual property protection? Like what numbers could we use to measure intellectual property protection?
how long patent protection is.
Yeah, that's the most natural one, right? It's just the patent life, right? So in the US, patent life is 20 years, right? If you assume a 5% interest rate, you can then ask, like, what fraction of having a patent for an infinite length of time of the value comes during the first 20 years. And that's calculation is just 1 minus 0.95 to the 20. And that gives you about 64% of the full life of a patent you get, which is in that range we were talking about, right? So that gives you a sense that US patent protection might be somewhere close to the right range. Now, given that patent protection is not totally complete during those times, you're probably getting even closer, right? We should also be taking into account in the deadweight loss effect, not just the reduction in demand, but also the reduction in follow-on innovation. And you should also take into account disclosure as being sort of part of the consumer surplus that's generated by the patent system. So that's not taken into account in this analysis. But an important thing to note is remember that Becker said that in situations where crime was very elastic, we should have more punishment versus the other. I think similar thing, which is not true in the US, is that patent policy should probably differ by industry, right? So industries with high elasticity and a low deadweight loss should have less, and low elasticity and high deadweight loss should have less patent protection versus industries with the opposite. And I would argue that the tech industries are probably ones where, as Daiichi was saying, there's a lot more self-motivation, and lawsuits have been a really costly drag on the industry. And therefore, there should probably be less intellectual property protection in high tech versus in pharmaceuticals. There's huge costs of innovating. So things are likely to be quite elastic. And the deadweight loss is somewhat smaller because the products are much more discrete, like what the chemical components are. And therefore, I think there should probably be more intellectual property in the pharmaceutical industry. But our patent law doesn't allow for that sort of differentiation. And that's a natural thing to have. Yeah, Eric.
Wait, is that true? So like, what about like creative patents, like Disney patents? Are those patents or those?
Those are copyrights.
Okay, but all patents are treated the same, like biological and technological. And
No, copyrights are different from patents.
Okay.
But yes, all patents are the same. I mean, which is crazy. It just makes no sense.
Is there a distinction between like a physical patent or like a purely like just like an algorithm-based one? Like any
Yeah, there's what's called business process patents versus other types of patents.
So when you patent, the one important thing is like how hard was that thing that you're patenting to get? For example, if a new technology comes, and with this new technology, everybody, the first person that think about it, they can come up with 10 things, but the first person that runs and like patent everybody, all of them, is just getting all of the benefits without adding anything to society. So like we have to add that, I guess.
Yeah, so there is something called, in order to get a patent, you have to be novel, non-obvious, and useful. And that's sort of trying to get at some of these issues, but it's a totally 0-1 thing. It should really be like how much protection you get depends on the Yeah, Chrissy.
But there are also some people who do like preemptive patenting, like before they know that there's a full process.
Yeah.
You know, you only have to have so much of a process laid out to like write up your patent and
Yep.
get it approved. So, I mean, it doesn't seem like doing that really benefits society because it's just somebody saying, oh, I thought of this first, like I thought of a hoverboard before
Yeah.
anybody could create it. But, I mean,
Well,
with
that's why they have the usefulness requirements. You know what I mean?
Yeah.
Because you're supposed to sort of like enable. It has to be enabled. Like people have to be to the point where like you can actually implement it.
Yeah, but those patents have actually been granted.
Well, no, I'm not saying that it works well, but I think that's the concept behind the policy. It depends on how good patent examiners you have and how many resources you give them, and we give them very little. So,
I mean,
yeah, Daichi.
isn't that also captured by like the elasticity of reward? Because if it's something that's really obvious and like doesn't require that much creativity or cost to produce, then it's like not an elastic thing. But if it's
Yeah,
something that you have to put in a lot of resource, then
Yeah.
you want a lot.
I agree. Yeah. But again, it's sort of 0-1. If you get protection, you get full protection, and you should really sort of have differing degrees based on, yeah. I mean, to some extent that happens because the courts might not uphold it ex post. So your probability of really having your patent enforced depends on, so there's a little bit of that, and there's some work about that, but I think it probably could be much more well calibrated. Okay, so while this is sort of the basic trade-off, many other tools are used to encourage innovation. So R&D subsidies are given in the US. There's extensive tax credits for R&D. The National Science Foundation gives out grants. Also, there are private subsidies through labs for like to try to get companies good PR by like them doing fundamental research. Prizes or buyouts of patents are another way to encourage innovation. So historically, this was quite popular. Governments used to buy out patents to reduce the deadweight loss and give more rewards to the innovators, or they would list prizes ex ante that if you came up with something, you would get a prize. So the French government did that a number of times, and the British government. And this is getting popular again with the advent of X prizes and so forth. There can be subsidies for purchasing innovative products. So one argument that was often given for like subsidizing green technology was to like incentivize new innovation in that area because they knew that they would have a market based on those subsidies. Patent length and breadth is another trade-off. You could give longer patents but then less stringent protection, or you could have shorter patents but stricter, and there's some trade-off between how you give the rewards through length versus breadth. There's these novelty, usefulness, non-obviousness requirements, and there's limited work on exactly how those should be interpreted or applied quantitatively and so forth, whether elasticities are the key factor or whatever, so that's an interesting issue. There's also division of profits between sequential innovations. So, if I invent something and then you build on it and someone else builds on it, how should the profits from the eventual product be divided between us? That's an interesting question. And the trade-offs in using these different tools are all different. So, when you think about research and development subsidies versus, and corporate taxes are sort of the opposite of that, right? Because if you tax the firm's profits ex post, that reduces their incentive to innovate ex ante, right? So the benefit of giving more subsidies, it helps internalize consumer surplus, but the cost is that you may want to redistribute away from entrepreneurs. So you can think of that as being like the key trade-off in corporate taxation and R&D subsidies. And the overall gain that you get from having that policy tool available to you is it allows you to separate the issue of sort of targeting towards certain types of things versus sort of the overall level of innovative activity that you get. My job market paper was about the trade-off between intellectual property versus giving prizes or subsidies for innovation. And